Okay, so we are creating our hexagon here with our 30-degree angles. That's a consistent line. And so we'll set up our centers, and we're using 8-inch sides for our hexagon, and we're going to draw it at 1.5 inches scale. So we'll start at the center, and we'll measure 8 inches on either side to make sure that we're going to stay symmetrical, and then we can start creating our sides. Very simple. We've established our center by following it down from the rectangles above, correcting our diagonal. The intersection is now the center. And 8 inches and 8 inches. We'll go on either side, put our 0 in the center, and create an 8-inch face. So we're counting our 8 inches here. That's 3, 6, 7, 8 inches on the 1.5 inch scale. We'll do the same thing on the other side. We could actually put 8 inches. We could put in the intersection and mark off 0, and that will give us our other 8 inches. Now that we've established the armature, that 8 inches, we can connect our 30-degree lines here. We'll get this face to there. We'll get this face to there. And then we can shoot our verticals up. So we've got our 8-inch face, our 8-inch face. Where that intersects, we'll go vertically with our triangle, up. Where that intersects, we go down. If you want to measure 8 inches on here and 8 inches on there, we'll finish our hexagon, the regular facing. That 8 inches should actually occur right at the intersection here, and it does. So that point is here, and then that point would be there. Let's measure 8 inches again. We can put our 8 inches at this point and this point. We could almost have kept that construction just as it is and just intersected where those faces meet the center line, because that would be our intersection there. And at that point, if we measured this leg, we would have our last intersection. So we've pretty much constructed our hexagon there, ways to check its accuracy. As the lines line up at the intersections on either side of the axis, right? So we have our construction lines. Let's just heavy up our lines a little bit. This becoming the regular outline of the hexagon. And we'll flip it around and get these points a little bit heavier so they pop out in front of the layout lines. We begin to see a little bit about the hexagon. And then, as in any geometric shape, we begin to see what that means. This is just a regular hexagon. Each side is the same, and each side is 8 inches. But the other quality would be, suppose like we did with the pentagon, we connected our intersections, and we connect our intersections here. Let's say from the center, you would see that intersection. In the other axis, we turn it around, and we connect the other vertices, just a little bit heavier. You kind of have that pattern, almost like the square pizza where you have the 6 pieces, the 6 equilateral triangles that make up the hexagon. Like we've drawn here, these are made up of equilateral triangles. If you look at this and you use line weights in our first exercise, where we're doing heavy lines versus light lines, you'll begin to see this might remind you of your child's version of a box drawn in axonometric. So rather than keeping it flat and seeing 6 flat equilateral triangles, creating a hexagon. Let's heavy up some of our lines, heavier than the others, and see if we can create a spatial feel to this. So we'll just take the top and the front, and I think if you look at this, you begin to see that what's happening is you get a little bit of spatial play with this. And what you're creating is your axonometric cube. And we'll talk about axonometric later, but this will be a little lead into that. You see how these lines are heavied up so that when you look at this two-dimensional regular hexagon, you could almost read it as a three-dimensional object. These are all 30 degrees, 30 degrees. This is like one face of the cube. This is another face of the cube. This is the top face of the cube. And these later lines are the hidden lines of that cube. But it's basically a regular hexagon. And it'll allow you to see the space implied in two dimensions. If we were to measure this along an isometric axis, we could say, okay, each face here is 8 inches. So this is the axis, this is the axis, and this is the axis. This is the vertical, and that's 8 inches. And this is the horizontal, that's the top. That's 8 inches. So if we did our hatching, we would say these are our 8-inch spaces. And that becomes the regular hexagon. And now our last geometry is we'll just play a little bit more with the 30-degree axis and create a grid that's drawn on a 30-degree axis rather than the grid that we drew in exercise 1 of last session. We have the centers again from the blocks above and the blocks aside to us. We're going to try 3 inches equals a foot scale and make a grid that's about a foot square or rectangular. So again, I'm going to take my 30-degree angle, centered on the block. So I've got my center. I'm going to create my armature, my axis of 30 degrees. Turn it around this way and get my axis of 30 degrees this way. That establishes the framework of my geometry. And I'm going to make a 1-inch grid based on a 3-inch scale drawing. And it's going to be 12-inch by 12-inch on the diagonal altogether. So here's the diagonal. So I'm going to put 6 in the center and 6 on, so then I go 1 foot on either side. So it'll be here to here. And I'll do the same thing on the other direction. See how that looks. Another guideline here. They should line up here. Another guideline there. Draw our rectangle at those intersections and these intersections. Okay, now this is the measuring line, and that's the measuring line. That's the 12 inches by 12-inch diagonal. And now I'm going to mark off all of my 1-inch increments. So the 1-inch increments on this diagonal, just lay down your 3-inch scale, 0 on one end, 12 on the other end, and tick off every inch mark. There's 1 inch, there's 2 inches, and 12 inches at the end. And then we'll do it on the other axis here, 12 inches this way, 11 inches, and 12 is right on. So that becomes the marker for all of your 30-degree lines. And now we'll use our tick marks with our 30-degree side to go from all our diagonal lines. So hit that tick mark using the rectangle perimeter that we described. Get into the corner. So you've got all the right to left diagonals at 30 degrees. And now we're going to get all of our left to right diagonals at 30 degrees. So turn your adjustable triangle over, and again work from top to bottom. And you've got the top there in the corner. Now work your way down. Okay, so now we have that little lattice, that grid on diagonal, 30-degree diagonal. And then we'll close up the rectangle to emphasize those lines a little bit darker so it's contained. Punch up our line work a little bit more hand pressure, a little bit more weight. Create the grid, connect the verticals. Ride your hand on top of your triangle to move it. And there we have the 30-degree isometric grid at 12 inches in 3-inch equals a foot scale. I want to just indicate the dimension of these diagonals are 1-inch pieces. So we're just kind of showing this bit of dimension with our 30-degree axis.